so that our YouTube people.
I'm going to use my camera to make a call, so I'm going to drop temporarily and then rejoin. So
okay.
I'll just come in quietly because I think we're getting ready to start. Well, we got 5 minutes.
Yeah. Well, so, I just started
that
the YouTube
way.
stream.
I also set Joy up for possibly minutes, but it may or may not work. If I come back in and I'm asked to take minutes, then I'll know it didn't work. I'll be right back.
That was a pretty clever plan, didn't you think, Joy?
Yeah, he left, so I can't say anything about it. Makes it hard.
He's a sneaky one.
Hey, I see a couple of our new members here already. It looks like Marcus Clark, you're new.
Yeah.
Welcome. Tom Morris, you're new too, aren't you?
I'm new too, yes. Yes, I am.
Oh, good. Well, welcome.
Thank you.
I'm the treasurer, so I'm the one you've been communicating with.
Nice to meet you. Nice to meet you.
He's head of the Traverse City Lowbrows.
Yes.
Yeah, points north.
Well, we got Brian close there, and he's got you trumped as far as distance goes, eh, Brian?
Oh, is he up here too?
No, I think, aren't you in Nevada?
Montana, I think.
Montana, yeah.
Yeah, he's in Montana.
A ways away.
Yeah. Mm-hmm. Yeah.
John Venius, he's relatively new too, I believe.
Hello, good to see you guys.
Hello.
Yes, John? So did you pick out a new telescope yet?
Still thinking about the SCT, maybe an 8-incher. Seemed like that would still be relatively transportable. Though I've heard the 6-inch is even easier to move around.
I have an 8-inch, and I can say that they're a little bit on the bulky side if you're moving, especially if you have a hard case for it. I missed my 4-inch a whole lot. It was very, very portable, and just grab it and go.
Yeah, so is that a refractor? Pardon?
I have the 6-inch, and that's a great size.
Oh, well, that's a good endorsement. I wish we could have one of these get-togethers where I could see the 6-inch and the 8-inch. It might make it easier to decide.
It'll come together.
Yeah, I believe the 6-inch is considerably smaller and lighter than the 8, is it not, Pat?
Seems like
I don't have an 8, but the 6-inch is a really nice size. The astronomy department bought one as well, and so you can get a hard case for it. I think actually it might even go in the overhead compartment if you don't have the tripod or anything. So, but it's a real nice size. The one thing I didn't like about it was the finder, because I'm always squinting down behind it. So I brought a right angle finder from Orion and put it on, and that makes the alignment just so much easier.
Mm-hmm. One thing I was thinking on the difference between the 8 and the 6-inch is that the 8 has considerably more light gathering capability. If it's like the area is pi r squared, you're squaring 4 is 16 versus squaring 3 is 9. So there's a ratio of more light on the 8-inch by a ratio of 16 to 9.
Yeah,
at least in my head anyway.
Well, I think you're on the right track with that, because with the 8-inch, the proportion of that center obstruction is a lot less for the total area of the objective end. The 6-inch, it takes up a greater percentage, I think. So I don't know if the section area is all that much different on the 6 than the 8.
Well, they actually have the same center section, so
yeah,
between the 6 and 8.
So I'm seriously thinking of buying one of these wheelie systems, probably from JMI, to wheel it out of my garage into the driveway. It just makes it a lot easier to move. That's something you might consider too if you're going to get the 8-inch.
So I had built a cart like that, and I built my own cart before I built the observatory. So I was doing that, rolling the cart out, and that it was fast to set up. The issue with that though is you're still in the water and the dew on the ground and things of that nature. If you're buying a Celestron version with one of their mounts, you can get StarSense, and you get that auto alignment system, and that is really nice, extremely nice.
Yeah, I guess I would be leaning toward doing something like that.
Yeah, I have an Ioptron AZ Mount Pro, which is kind of like the Celestron with the StarSense and all that. It pretty much figures out everything, and bolt everything together, hit the switch, it does its alignment, and then points you at a bright object in the sky that's convenient, and you center it and press enter, and you're ready to roll. It's really great. And I think the Celestron product that works very similarly, if I'm not mistaken, right, Don?
It's pretty much. The only difference is you have to, the very first time you use it, align the scope to that camera, and after you do that, it remembers. So, and the go-tos are so close, it's amazing. Yeah, it's so easy.
Welcome.
I was very impressed with this dark sky New Mexico remote control observatory, although I wouldn't go that way, at least in the immediate future, but I thought that was very neat as well.
Comments, Brian?
I'm going to do another live show on the 31st. We'll be looking at Orion and all the stuff in Orion.
Yeah, I've enjoyed that. I've seen a couple of your shows already.
I'm getting ready to take a snapshot of a crescent moon right now.
Dun, dun, dun. Yeah, Brian's an excellent presenter. He puts on the nicest show and well thought out, well narrated and all that. It's like watching Cosmos, but locally produced.
Yeah. Thanks, Jeff. The check is in the mail.
Hey, I gotta make some money to pay for all this junk. I'm gonna turn that off.
So we have a question for you, Brian. Are you a SLU member? Maybe you should explain that you've got that observatory.
Well, SLU is wonderful. It's a wonderful way to kind of take your own pictures with a fancy telescope for a very low amount of money. And so they make it very easy for you to borrow a big telescope on the Canary Islands. So I highly recommend SLU. It's really fun. And also you can eavesdrop, right? You can eavesdrop on other stuff. So that's how I got started.
Yeah, Cayenne she's a SLU member, and I don't know what's her level. She's recognized your picture, and she's like, he's a SLU. And so she said to ask, what level are you now?
I have no idea at this point.
But yeah, she does, and she's recognizing everybody's background right now. She's like, Course Nebula, Orion. Like,
SLU is fantastic.
Yeah. So if anybody doesn't know SLOOH, it's SLOOH, and they're digital, and you can rent the time and take pictures using the Chile and the Canary Islands telescopes. So she hangs out there pretty regularly.
Okay.
Well, it looks like we sort of settled on about 37 participants here. People are rolling in slower than they were. So I would like to go ahead and get us started, but first order of business would be if we can get a vice president to take minutes for us.
Yeah, I guess that's me.
All right, thanks, Joy.
Yeah.
Hang on. I keep getting, My view keeps switching on me. It's a little irritating. Anyway, so you've all joined the University Lowbrow Astronomers, actually our first meeting of 2021, which we all hope and expect that it should be a better year than 2020 for sure. And we are a group of 150 some. We'll get an update a little later, members. And I'm actually rather pleased to see several of those new members are actually in the meeting here with us tonight. So welcome aboard. And hopefully sometime in the not too distant future, we'll actually be able to meet live again. So, but for now, Zoom has been serving us fairly well. So with that, our tradition is to have our guest speaker. Oh, just a reminder, just for business purposes, to remind everybody that we are being recorded on YouTube. So you got to be good. Anyway, our first order of business is our guest speaker, and then afterwards we'll do a business meeting and get reports from officers. And our guest speaker tonight is Dr. Pat Seitzer, who earned his Bachelor of Science from Georgetown University and his PhD from the University of Virginia. He is an instrument scientist for the Space Telescope Science Institute and an astronomer at Kitt Peak National Observatory, as well as Cerro Tololo Inter-American Observatory in Chile. In addition to being a professor at the UofM, he is a longtime honorary member of the Lowbrows, and he's presented to us actually many times over the years. And it's nice to see him back. Pat conducts research in space situational awareness and optical studies of orbital debris using the UofM's 0.6 meter Curtis Schmidt telescope at Cerro Tololo. He and his collaborators work to assess the total amount of debris at geosynchronous orbit and then follow up with spectroscopy using the 6.5 meter Magellan telescope to characterize particular objects. His interest in orbital debris and the need for astrophotography to perform his work combined to get him involved with the challenges presented to professional and amateur astrophotographers by the Starlink satellite network. That is why he's come to us tonight with a presentation called Large Constellations of Satellite in Low Earth Orbit and Optical Astronomy. So with that, let's please welcome back our good friend, Dr. Pat Seitzer.
All right, thank you, Charlie. Let's see if
Take it away, Pat.
I'm going to take it away. Let's see what we've got. So what I want to talk to you about is large constellations of satellites in low Earth orbit and optical astronomy. And so this is a beautiful night sky view of an all-sky camera taken somewhere, the Milky Way going straight overhead. And so the question that you may have raised over the last year and a half since the launch of Starlinks is that there'll be thousands, or if not tens of thousands, or perhaps as many as 100,000 new satellites launched into Earth orbit. Many of them you will see, and some of them you'll be able to see all night long. So the questions I want to help you address are, should you take up new hobbies? What should you do with your telescopes? Should you give them to the astronomy department for a tax donation? So I hope to be able to address these questions for you. Let's see if I can get my thing to work. Okay, so this was just an all-sky camera that I set up at the SDO, the Seitzer Driveway Observatory. Field of view is 170 degrees, and it's a 15-second exposure. There's the International Space Station. There's a tumbling rocket body, and there's a bunch more satellites that are in this field that you just can't see. In fact, there's probably something like 600 satellites in this field of view, most of which are too faint to be seen. And this is the view before the large Starlink constellations came in. And what really got everybody's attention and panicked astronomers was the launch of the first Starlinks back in May of 2019. They were easily visible to the eye in times, and in fact, you could probably see them from downtown Ann Arbor. These were them just after launch in a temporary parking orbit. They were probably second magnitude. And people said, wait, they're planning to launch 100,000 of these. Will they be visible all night long? Is this the future of the night sky? Are we all doomed? And I'm here to tell you, yes, donate all your telescopes to the astronomy department and take new hobbies. But no, that's not the case, okay? Sad for me to say that. Let's just make sure I get this thing working. So here's a famous example taken with the Ceratololo 4-meter telescope, and it has 19 Starlinks crossing the field of view. This is 2.2 degrees. It's more than 4 times the diameter of the full moon. These satellites were taken just after, about a week after launch. It was an accidental exposure. That is, they were not planning for the Starlinks to go across, but they did. And so it sort of made a mess. It's a pretty picture, and it's been repeated hundreds of times. So here's another example of what a Starlink will do. This isn't a Starlink. This is a rocket body which was launched back in 1963. And I asked the 4-meter people to take an image of it that went across the field of view. It's been up there. It was a 60-second exposure, even though it took less than a second for the satellite to go across this field of view. And the magnitude of this satellite ranges from 4th to 10th. Large telescopes are so fast and so efficient that even though this exposure time as it crossed each pixel was probably a millisecond, it still saturated the detector. So this shows you an example here. This was a cross section across this, and you can see that it's flat topped. So this particular object going across that, even though it was a few milliseconds to cross each pixel, was saturated the detector. And this gets professional astronomers, particularly the builders of very large telescopes, in trouble, are very worried. Here's a fainter object. This is a Russian rocket body, I believe, or satellite, still in orbit. Both of these are dead. Both of these are space debris or junk. So why are you concerned? Well, you lose information in pixels that anything under these streaks will either have a lower signal to noise or will be wiped out. The signal will be lost entirely. You'll have crosstalk in the electronics. You could have ghost images. You could have possible residual images. So just to explain again that when you're taking pictures of the night sky and you have a satellite trail across it, the exposure time which matters is not the exposure time if you did a 5-second or 15-second or 30-second or 300-second exposure. It's the time it takes the satellite to cross one picture element in your photo. And that's typically with these big telescopes and small pixels, it can be milliseconds. Even if you had fairly sizable pixels like 10 or 15 seconds, it'll still be tens of milliseconds. That's a very short time, but these objects can be so bright that it may saturate your detector. One thing to note here is because of this guy, Isaac Newton, who keeps showing up from time to time, the higher altitude satellites have a lower velocity, thus they take longer to cross your pixel, and they'll have a no longer effective exposure times. Also for big telescopes, really big ones like 4 and 8 meters that some of you have in your backyards, the low altitude satellites will be out of focus. Strange as it seems, if your telescope is focused at infinity and you have a large, bright satellite, or large, bright satellite, it will be out of focus. So here's another example of what you can see. This was a Titan rocket body, which was launched into GEO in 1968, and it's still tumbling around out there, confusing everybody. And here you can see that there are groups of 3 flashes as this object tumbles and goes across the field of view. I advise my professional colleagues that if they see something like this and their automatic software picks up these things as galaxies and they have a linear galaxy cluster, they probably ought to check the image before they book their flights to Scandinavia for a Nobel Prize. So anyway, when are satellites visible? Well, the observer has to be in darkness, and that depends on the latitude and the time of year. The satellite has to be in sunlight or penumbra, not in Earth's shadow. That depends on orbital inclination, altitude, and the time of year. the brightness of the satellite, and that'll depend on the angle between the sun, the satellite, the observer, and a whole bazillion other characteristics of the satellite. Whether you're seeing specular or diffuse reflection, what the attitude of the satellite is, what the shape of the satellite is, what the materials on the satellite is, we can go on forever. And there are people that just specialize in trying to determine what the shape of the satellite was from the observers. So the telescope has to be in darkness and the satellite is in sunlight. And this is from Visorsat. It's just a diagram, and it reminds you that the Earth's shadow is a cone. It's not a cylinder, as you see sometimes in plots. And so if the satellite is out here, you'll see it. You'll be here, and the satellite is out here, you'll see it. If the satellite's here, you won't see it unless the satellite glows in the dark. And I'm working on a project to make that happen, but that's for another talk. So anyway, what's the current situation of satellites in Earth orbit? Well, this is a plot from the NASA Orbital Debris Program Office, which shows you most things larger than 10 centimeters to the end of 2019. And so back in 1957, when Sputnik 1 was born, or was launched, there were 2 objects in Earth orbit. One was Sputnik 1. The second was the rocket body. The rocket body was junk or debris. So thus the initial catalog of objects in orbit was 50% junk. And it's gotten better or worse since then. So what astronomers and space safety people are interested in is the top curve, which is the total objects that the U.S. Air Force tracks. Well, most of them. And it's larger than 10 centimeters. So these are this is debris fragmentation, when a spacecraft collides with another spacecraft and breaks up or explodes. And then you have active satellites down here and various rocket bodies and things. So our interest is the top curve. These 2 spikes here are due to deliberate anti-satellite test by our friends in China back in 2007. And then 2 years later, there was an accidental collision between 2 satellites, an Iridium satellite phone system and a dead Russian satellite. So, but it's the top curve here. We don't care what it is. All we want to know is how bright is it? Does it reflect sunlight? So if I calculate through and ask how many of those are visible, how many of the 19,000 objects that were here in the catalog, how many of them are visible above you? And this is for a site in Chile where I used to love to go, and I would still love to return at some time. And you can see that in the middle of the night, let's see if I can get so the 2 red lines are astronomical twilight, and I don't have to explain to this group that that's 18 degrees below the horizon. Okay, and so these run from nautical twilight of -12 in the evening to nautical twilight in the morning, and you can see how the number goes down in the middle. But even in the middle of the night, right now, there'll be between 600 and 700 satellites visible to you, and visibility is defined as you're in darkness and the satellite is in sunlight. So in principle, you could see it if you had a big enough telescope. Excuse me. Most of this stuff is too small for you to see, even with a big telescope. It's tracked with radars. So here's another scary plot, and this is much more recent. And this shows you the number of objects as a function of altitude, okay, for 3 dates: January 2000, January 2010, and October 2020. So back in January 2020, you had probably 100 objects in the altitude bins. Life really got interesting by January 2010, when after that anti-satellite test and that accidental collision occurred, those 2 events correspond to about 30% of the tracked objects in Earth orbit. So 30% or more of the tracked objects in Earth orbit come from those 2. If we look in October 2020, we see the growth has increased tremendously below 600. This spike here is Starlinks. Okay, that is SpaceX alone are those objects there. Okay, and these are CubeSats, which have been, mostly these are CubeSats, which have been launched into Earth orbit. So life is getting crowded. So, you know, you have to ask, if 600 to 700 objects are now visible at any time during the night, why do we care if another 100 to 500 are added from these new large constellations? And the answer is brightness. These new satellites could be brighter than 99% of all objects in Earth orbit now. For example, by the end of 2020, SpaceX added another 900 objects. The plot behind that I just showed you, out of date already. So what do we want to talk about? So here's some examples of large constellations that are coming. These are, see what we got here, Amazon Kuiper, that shows you the altitudes, the inclinations, and the number of satellites. The one that astronomers were really scared of was OneWeb, and I'll show you why in a minute. The altitude is 1,200 kilometers, the orbital inclinations, and the number of satellites. Fortunately, they were originally going to plan to launch 47,844 satellites into 1,200 kilometers in the next 10 years. Earlier this week, they announced and said, well, maybe we'll only announce 6,372 satellites into that 1,200. So for astronomers, this reduction of 7.5 in the number that they're going to launch is huge. But it could still be a problem. Now, and then there's our friends at SpaceX, which are launching in these altitudes a total of 34,408. If everything they have filed with the Federal Communications Commission, which is who they have to file with if they want to transmit to the Earth, their radio waves basically need a visa to come into the United States from space. So this is data from public FCC filings. And so we want to know, and I'll show you a video shortly if we can get it to work. And they represent over 70% of the known constellations of 107,000 satellites planned, filed with the FCC, or launched in a press release. So what does this mean for your hobby? You should go do something else. So let me see if I can get this to work. Hold on a minute. I'm going to stop the share for a moment, and then we're going to share again. And let's see what we got. So this is from our good friends at AGI. Oops, that wasn't it. I hate this stuff. All right, let's go back here. Sorry, folks. And so the constellation and the number of satellites in the year is shown on the left. And that's the sun. So I think you can see that things could get really crowded up there. Let me just make sure. Okay, let me share the screen again and see if I can find my So let's continue our story, because that showed the satellites when they're at their operational altitude. That is, when they're fully deployed and actually making money for the company. But there's actually 3 phases of a satellite's lifetime. There's the initial mission phase, which consists of launch, a checkout in orbit, parking orbit, and orbit raising. So for example, for Starlinks, they're launched into a low Earth orbit and then they're boosted up to 550. And so it was this initial mission phase, this basically this checkout and parking orbit, which produced these things, which is what people got really concerned about, that the night sky was totally lost. Finally, there's an operational phase, which is going to be the simulations I reported here. And this is the Starlink in its operational phase. These are big satellites. This is a solar panel, and this is the equipment, the payload. You can't see, but underneath are the antennas facing towards Earth. Okay? And finally, the deorbit phase. You can't leave all this junk up there. Well, you can, but you shouldn't. Like, for example, the guideline now is after the satellite is at its end of mission, you're supposed to lower it and burn it up in the atmosphere, within 25 years after the end of mission. Well, 25 years is a long time. If a car breaks down on the highway out on 23, you don't leave it there for 25 years until somebody comes and picks it up. You'd like to do it much, much sooner, certainly within 1 year, and that is what the operators are planning to do. So even though the guidelines and things that they have signed up to abide by say 25 years, they're trying to get them down as quickly as possible. So with that, the other thing is the brightness will be different in all three phases. The distance from the observer to the satellite's different, the attitude and orientation of the satellite different. We don't know about failures. So suppose you have 1% of 100,000 satellites fail every year. That's 1,000 satellites failing. After 10 years, it's 10,000 dead satellites in orbit, gradually coming down and perhaps flaring as they are uncontrolled in attitude. So what I'm going to do is I'm going to show you what we did to model the Starlinks. When will they be visible? The telescope is in darkness, the satellite in sunlight. Satellite's more than 30 degrees above the horizon, and the red lines are in plot. Now, this is just the initial 1,584 satellites of the first SpaceX Starlink constellation, and when it will be visible from the Vera Rubin Observatory in Chile. This is the LSST project. It is the largest, baddest, fastest telescope under construction. It will do the entire night sky visible from Chile a couple of times a week. And it's an equivalent aperture is 6.5 meters. So anyway, so here's one in winter, okay? 1,584 satellites at 550 kilometers. And you can see these are the red lines. And so most of the time during the night is dark, okay? You've got past, maybe past astronomical twilight. There'll be a couple of more satellites visible, but basically they're all invisible for most of the night. The steady state number is 9 satellites above you, between 7 and 9 satellites visible above you. If we go to spring and fall, say like March or September, the nights get shorter, and they're starting to creep more and more into the dark time of the night, past astronomical twilight. But still, you have many hours during the middle of the night when things are dark and you don't have to worry about these satellites. So if SpaceX was to launch 30,000 at this altitude, you would see that you'd be okay down here because most of the night would be dark. If you're working in twilight, well, probably not the thing to do. And even if you go to summer, and this is December 21st at Rubin Observatory, minus 30 in Chile, minus 30 degrees, or it would be June 21st here in the Northern Hemisphere, you still got a couple of hours in the middle of the night where things are still free. Let me grab a swig of water. Okay, fine. Well, you don't like that, but if the conclusion is if SpaceX was to launch just 1,584 satellites at 550, you'd be okay. If they were to launch 30,000, you multiply these numbers by 20. And so you'd have 180 satellites above you or 40 or something moving. Now, suppose they had, their original plan was to launch to 1,150 kilometers. Well, now the situation changes. Their original plan was to launch to 1,150 kilometers altitude. They're not doing that anymore. They are bringing everything down to under 600 kilometers altitude. And there are various reasons for this. One of the reasons for doing these large constellations is a term called latency, how long it takes the signal to get from me to the destination. These are internet satellites. How long does it take for me to get from the signal to get from me to wherever it is it's going? You can launch it to GEO, but then the delay time is at least a quarter of a second. If you're at 600 kilometers, it's under a tenth of a second, or it's under, actually, I think close to under 100th of a second. So you really can keep them close. And the amazing thing is, it is quicker to transmit the signal to orbit and then back down than it is to send it via fiber. Let me repeat that. It's quicker to send the signal to orbit and back down than it is to send it to fiber. So if you're doing high-speed gaming, this is important. And the reason is that the speed of transmission in fiber is 40% slower, just because of the index of refraction of the optical glass used in optical fiber. So it's slower to send signals in fiber than it is to transmit them to space and bring them back down. So the conclusion of here is that in the middle of the night, you're going to have, in summertime, you'll see these satellites all night long, okay? And you can multiply this 10, you want to multiply 10 by 10, if it was 15,000, or you want to multiply it by whatever large number you wanted. Suppose, let's see what we got here. Yes, okay. So here's a sample constellation of 10,000 satellites. 100 planes with 100 satellites per plane, and the inclination is 53 degrees. This just shows you how much difference altitude makes on the visibility of these satellites. So the satellites will be fainter at higher altitude, but there'll be more of them visible during the middle of the night. And this is for looking at an elevation of more than 30 degrees and air mass of 2. And so this is summer, June 21st or December 21st in the southern hemisphere, the real hemisphere. And you can see that it goes down, and you still got about 40 satellites visible in the middle of the night. And this was the 500 kilometer, you've got dark time. Okay, so just after astronomical twilight, the number starts to go down, and just before astronomical twilight, the number starts to go up. But you still have dark time in the middle of the night. Twilight between nautical and astronomical, well, that basically, there's no loss of satellite visibility then. Suppose OneWeb had launched its original constellation of 47,000 satellites. Okay? Now that had 3 different inclinations in there. There was a sample, there was a group of satellites at 40 degrees orbital inclination, a group of satellites at 55 degrees inclination, and a polar orbit. The total one is here. Basically, in the middle of the night, in summer, you would have 500 satellites above you at 1,200 kilometers altitude. Most of them were coming from the 40-degree inclination bracket, okay? And 55 is a bit less, because the number visible depends crucially on the orbital inclination, and you see the most of them when it's closest to your latitude. And the latitude of Tololo and Rubin Observatory is around -30. So fortunately, we can reduce all these numbers by a factor of 7. That's for OneWeb. What we don't know is what countries like China and Russia, and that you can be sure they are not going to file with the US government for permission to launch. So what's the current situation on these satellites while they're at station? So I'll show the next slide, shows you what the SpaceX Corporation did to try to minimize the brightness of their satellites. And the current model is called Visorsat, which was launched back in June. And this is 1,677.1 second observations from a Russian facility, and the median V magnitude is 6.48. The goal was 7. The goal was to get all of these satellites at all times fainter than 7th magnitude. And there's a study on the brightness, how faint the human eye can see, and that was sort of the round off where Most people will see between 5th and 6th. There will be gifted people between 6th and 7th. And there are some really gifted individuals that at a really dark sky site with no extinction can see down to claimed numbers are 8th magnitude. But the American Astronomical Society adopted a figure of about 7, as what the operator should target to. So their first satellites were at 5th magnitude, which you would have been able to see. Their new satellites are at 6.5, and so we hope that they will continue to work on this to get to 7th magnitude, and thus it'll be much better. For the eye, for the astrophotographers, it's still going to be a problem. Okay, now this is a slide stolen from SpaceX, and their goals are to make the satellites generally invisible to the naked eye within a week of launch. And what they've done is their satellites are of a clever design, okay? They shapeshift. They change shape during the mission. So if I look here, well, after they're first launched, they're in a flat open book configuration, okay? And they try to fly them so that the sunlight bounces off the knife edge here, which will be pointed towards you. And that should make them much fainter, and you shouldn't see these second magnitude, these groups of second magnitude satellites going overhead as their orbit raised. And I think that's been generally successful. I don't see reports of these things and people panicking over them, okay? When they reach their operational orbit, they go into what's called open book configuration, where now they have a 90 degrees between the payload and the solar panel, and it rotates it so that this is nadir facing, is pointed down towards the Earth, because that's where the antennas are. And that's where the 6.5 magnitude comes from, when these things are on station and in their proper orientation. They put, on these most recent satellites, they put in sunshades on them to block the sun from reaching the downward-looking part of the satellite. And that appears to have reduced things by about 1.5 magnitudes, from 5th magnitude down to 6.5. A lot of effort put into this. SpaceX is very serious about this in trying to make these things as faint as possible. They were as surprised as astronomers were as to how bright these things were. And why was I surprised by how bright they were? Well, I was surprised by how big they were, how big the panels were, and I was expecting CubeSats or 3-unit or 6-unit CubeSats, which gets launched by the hundreds now, and you never see them because they're all at 8th or 9th or 10th magnitude. So you will see them maybe in your astrophotography. What about the OneWeb satellites at station when they're an operational one? This is 26,000 observations on 38 passes from a Russian facility. You got to love the web and what you can find out. And so it's bimodal, which we think is due to the phase angles, but the median V magnitude is 7.8, almost 8th magnitude. In most cases, you will never see these with the unaided eye, but you probably will see them with binoculars, and you'll certainly see them in, when you do astrophotography. So my feeling on this is large constellations at LEO, they're coming and coming fast. They could be brighter than 99% of the current objects in orbit. I think that's not likely to be the case. If we only launched one constellation of 1,584 satellites, we could handle this. But I think the big three are actively working with the American Astronomical Society to make their satellites as faint as possible. The big three are Amazon, OneWeb, and SpaceX. We have telecons with SpaceX about once a month, once every 6 weeks to discuss progress here. There has been 2 workshops that have come out, and you can go read the conclusions here. SATCON 1 was what was the impact of satellite constellations on optical astronomy and recommendations toward mitigations. So the recommendations there towards mitigations were keep them fainter than 7th at all times. keep them fainter than V=7 at all times, so they are not a naked eye concern. And also launch to 600 kilometers or below. The 1,200 kilometer ones are a real danger to astronomy, particularly to the Rubin Observatory. Although you would think they would be fainter because they're like twice as far away and therefore 4 times fainter for the same size spacecraft, it turns out because of their velocity across a pixel in your camera, they're traveling slower, so they're brighter that way. They're also more in focus, so the profile is much more concentrated than a defocused profile at 550 or 600 kilometers. So they're not as faint as you would like. And this is of concern to people that are building the cameras for the Rubin Observatory. Their problem is they cannot correct for the nonlinearity in the cameras if they're much brighter than, say, 7. And there was also a recent Dark and Quiet Skies report to the UN, which you can available here from the International Astronomical Union. And and I think with that, I'm fairly optimistic that designers, operators, and builders in the United States that have to go through the FCC, that they will keep them as faint as possible. Now, there are no laws, there are no guidelines, there are no regulations controlling the brightness of satellites. The FCC controls orbital debris, how much space debris you can create when you launch and when you operate. It controls the radio frequencies, what frequencies you can use and what power you put out on them. But nothing in the laws or the regulations anywhere say anything about the brightness of satellites. And the question is that a path you want to take? The American Astronomical Society's view is that we would rather collaborate than show up at your launch pad with pitchforks and lawyers. But, it may come to this at some point. We may need to have regulation. But then the question is, it's an international problem. Space knows no boundaries, no international boundaries in space. Isaac Newton doesn't care who launched you or what. He's going to do what he wants to do. So I'm reasonably hopeful for the big 3. Beyond that, I think the other concern is there are a lot of people launching large structures into low Earth orbit, particular radar satellites, and how bright they are in things is a matter of concern, and we'll just have to wait and see what the measurements turn out. So with that, I will stop the screen share, and if you have any questions, I'm happy to take them.
Hey, Pat, has anyone done a study about having so many constellations in Leo would affect the available launch windows for any rockets?
Yeah, and I'm sure that's been studied. But at this point, at the current population of stuff in Earth orbit, it hasn't proved to be a problem yet. But, it could be if you launched enough stuff. I'm not an expert on that stuff, and we'd have to find somebody who was. So I'm not going to comment on that. All I can say is you all need to get a new hobby and send me your telescopes.
Either way, you want those telescopes, right, Pat?
Absolutely.
Well, now you know why I do daytime photography, because the sky goes to crap. I can at least still take landscapes.
Yeah. So
I had a picture
that things will that we won't have 100,000 satellites at third magnitude. And you hate to pray for the failure of business models. But that's the thing that would probably be the best for all of us, is if the business models for many of these businesses failed before they launched. You don't want to have them launch and leave their junk out there. So,
yeah. Go ahead, Jim.
Has the IAU met to come up with guidelines, proposals that can be, negotiated between the foreign ministries of various nations so that you actually come up with something sane and has a force of law?
So has the IAU done anything? Well, the IAU was one of the co-sponsors of this Dark and Quiet Skies workshop, which the results of that went to the United Nations, to a United Nations Committee on the Peaceful Uses of Outer Space, UN COPUS, which is very interested now in the sustainable use of space. That is, this goes into if you launch 100,000 satellites at 550 kilometers, can you launch anything else, or do they all collide with each other and make launching impossible? So I think the implications of these large constellations is, it's just beginning to be shook out. 5 years ago, there were some people, concerned, but not at the level they are now. So I see a question from Brian on the chat. What about the satellites that are in constellations other than Leo? I'd hate to have Orion also degraded. Well, I think, Brian, just send me the code words for your telescope. The problem with Orion at -5 is that that's very close to where the geostationary belt is, the projected location of the geostationary belt. So if you were at plus 30 degrees latitude, it'll be around -5. So you should be able to get great photographs of geosatellites going through the station-keeping satellites going through the path there. Their median brightness is about 12. So that's not as faint. That's not as bright as you would see with the LEO satellites. The problem, there's a couple of thousand objects brighter than 18th at GEO. And once the satellite is not operational anymore, the orbit is unstable. So those little direct TV and dish TV things that you see, and they're pointing at one point in the sky, the satellite has to constantly maneuver to keep it in position, because otherwise the orbits are unstable, and they're unstable because the Earth is not a perfect sphere, and you have the moon and the sun, which are essential for human life, but for satellites, they make a mess. And so then the object starts to increase in inclination, and it'll go up to 15 degrees inclination and come back down to 0 with a period of 54 years, which, not surprisingly, is about when the 54 years ago was when the first objects were being launched into geosynchronous orbit. So you will see a distribution of objects, which in this case from the northern hemisphere will be from plus 10 declination to minus 20 declination, plus or minus 15 degrees of where the projected belt is. And so I would be very surprised if you don't see objects going through Orion.
Well, I can kind of vouch for that because I've got a picture of the belt and I've got streaks going above and below the belt during a 90-second exposure. So I guess it may already be happening.
Yeah, and so the first geosynchronous satellites were launched. Actually, the first object into geosynchronous orbit was SYNCOM-1, which was launched on Valentine's Day in 1963. And it failed as it was being inserted into orbit. And thus the initial catalog of objects in space at GEO was 100% debris. We humans had managed to put junk at GEO before we put an operational satellite.
We got to
try until it works.
Yeah, a couple more questions on chat, Pat.
Yeah.
Okay, let's see. No, you don't have dibs on Brian's mound. When we launch a military satellite, is there a concern of passing through a debris field? If you launch any satellite, there's a concern of launching through a debris field. And I've heard that there is some planning for that, but I'm not an expert, and I'll have to go check on how much of a launch window they have. They just got to vary it by 1/10 of a second to miss a possible conjunction, because things are traveling so quickly at orbit. Is there a potential but complicated and expensive technical solution for a large telescope to program in the orbits of the satellite and deactivate the pixels of the photosensors as they pass by. I'm not sure this negates the problem, but I'm curious about the technical possibility. Okay, so for a CCD, the answer is no. The only answer for a CCD is that you close the shutter. If you have just a few thousand objects in orbit, you can do that, okay? If you have 100,000 objects in orbit and you have 500 to 600, say up to 1,000 objects above 30 degrees elevation at any one time, and you're doing a lot of short exposures to cover as much sky, it doesn't work. It's simply impractical because you end up shuttering several times for even a single 15 or 30 second exposure. What I'm not sure of the other thing is that the accuracy and precision of the orbits of the satellites are not that well known, at least the information that's available to astronomers. And that was one of the recommendations of the SATCON-1 report, was to get the most accurate and precise information on satellite locations, description of their orbits, predictions of where they will be in the future, and make that available to astronomers. So do we have any other questions? So my office is 301A West Hall. I just repeat, my office is 301A West Hall. West Hall. Just leave your telescope outside the door. I'll get you the tax form.
Just let me know when you're going to leave the telescope outside of Pat's door, okay? Thank you very much, Pat.
I think it would be, one thing that would be helpful is if you take photographs that have satellite trails in them, particularly photographs that have more than one satellite trail in them, it'd be useful to make a catalog of those, just so document where and when it was taken and what the equipment was. And if the Lowbrows were to put together a web page on that, that might be useful for documenting when the problems are and just to show to people that, the night sky is changing. So
I'd be happy to take a couple of the photos I've gotten started. I said belt, I meant sword. So you've got the Orion Nebula, and you should see all the streaks that are going above and below it. So I don't know if it's on this tablet that I'm using, but I would be happy to start posting that, or maybe head something like that up with some of the images that that we're all taking. That actually sounds like something very useful for those images.
That would be great. That would be absolutely great.
Actually, we could probably set up a spreadsheet in the shared Google Drive, and at least the officers report it in, and we can record it down, and have Pat periodically check that if people are spotting the things.
That would be great. Yeah. That would be great.
Got a question for you, Pat.
Sure.
Yeah, this is Doug Bach. When you're talking about the main scope down there in Chile, I think you said it was.
Mm-hmm.
When they do their all sky surveys, they're taking single images, right, and then moving on to the next area of sky. Correct.
That's still a matter of discussion. The original concept was to take two 15-second exposures, a pair of 15-second exposures, and then take another pair. And now they're trying to figure out, well, should we do a 30-second exposure because we can go a bit fainter? I think that in the end, they will do two 15-second exposures just because of the number of satellites in orbit.
But one of their goals is not only mapping the sky twice a week, but looking for asteroids, etc. Right?
It's looking for asteroids. It's looking for transients. It's looking for objects that flare suddenly and then are never seen again, or flare on a periodic basis. So there's all sorts of things. The transients, the changing night sky is one of their primary purposes. It can be objects which are not moving, but which are changing in brightness, or it can be objects which are moving and changing in brightness. But the transient night sky is one of the major things that they're interested in.
Okay, the reason I asked that is that's what they're hunting for, which is what I figured. And we couldn't use any software and actually taking single frames. Couldn't you do any software like Sigma, Kappa Sigma clipping? Because that would also eliminate asteroids, etc. So I understood now.
Yeah, and once you get a trail through it, well, even if the trail does not saturate, any object that's under the trail, you have a lower signal to noise. And I'm not aware of any software or magic that can recover signal to noise once it's lost. So.
Well, was one of the tools that we use for when you stack 50 frames on a particular object is the clipping or the software that will clip transients. If you're not looking for transients, it will clip that out, and so you won't see meteors or satellites or anything in your final frame. That's all. There is software that allows you to take out transients if you wanted to do that, but it requires more than one frame to do that.
Yeah, I think Ken Cook has a question.
Yeah.
So the telescope this is Ken Cook. The telescope down in Chile, is it looking for occultations at all? Anything like that, where you're trying to find fainter objects? You're looking for a dip in the light curve. And you have to worry about, when you put this constellation up, you now have all of these things that are going to be blocking stars, right? At random, unpredicted times. So if you're looking for occultations, or if you're looking for dips in the light curve, does that present a huge problem? Even if you're going to make them dim enough so they don't screw up visual observing and astrophotography, if you're looking at actual light curves, is that a real problem?
It depends on the time resolution of your observation. In a 15-second exposure for the Rubin Observatory, you have a satellite that goes by at, say, 1/4 of a degree per second. The time in front of the star causes a diminution of far less than 1%. Okay? In fact, it's probably immeasurable. If you were doing high-speed photometry of stars and a geosatellite went in front of it, and I mean right smack in front of it, then you might see a diminution of 1%. But it has to be absolutely right smack in front of it. So for low Earth orbit satellites, unless you're sampling at 1,000th of a second on a bright star, then I don't think you have a problem. And certainly for LSST, the Rubin Observatory, it should not be a problem.
But in general, for observations where we're trying to look at light curves and over time, we have this now 100,000 random objects flying in front of the detectors, and we don't know where they are, and we have software that's looking for changes of that order of magnitude. A 1% change in the brightness of something is important, but I think most of those are done outside of Earth, not terrestrial observations. They're done at some of the Lagrangian points, right?
I think you have a lot of ground-based observations that are looking for transients, but the chance of most of the stuff that you see is low Earth orbit, or most of the satellites are low Earth orbit, and their angular velocity is so fast that if you're doing a 5 or 10 second exposure, you might see 1,000th of a magnitude change, which my guess is your noise is at that level.
Right. Just atmosphere. There's lots of places where you pick up that much noise in an observation like that. But it's an interesting problem. We're all of a sudden putting things that are going to be blocking starlight, depending upon where you're looking and what you're looking at. And so that's another consideration.
So I'll tell you, the one object that you probably ought to be concerned about occulting stars is the International Space Station, which is 20 arc seconds across at low Earth orbit. So that's a big thing.
What about those rocket boosters? Some of those look like they could do some serious impact on something like that.
Possibly, but they're big. They're as big as a city bus. They're tumbling. But I think all the numbers that I've seen suggest that at low Earth orbit, it's not a problem for occultation. So now, if people are flying things the size of Michigan Stadium, when Coach Harbaugh goes to orbit, the you know, at 1,200 kilometers or higher, then it could be a concern. But I think their speed is so fast that the change in the magnitude is just, you won't see it. I mean, if you're doing this sort of work, what sort of exposure times are you using?
I'm not. I'm just asking the question.
Yeah.
But so we need a like a 2001 Space Odyssey space station to really have an impact.
Well, ISS is probably about that size. I mean, that is a big structure up there.
Yeah, it's big. Very, very interesting to look at.
Yeah, I think we're a basketball school by now. We're no longer a football school.
Oh, that's right.
I was just going to say something like that, Adrian, that our basketball team is at least
we're back. Yeah.
Sadly.
Yeah, we won't send Coach Howard in orbit.
Let me just say one thing on International Space Station. It has been seen, even though it's in Earth's shadow, when it's passing over a big city, light pollution. So there are reported observations from Europe. Well, when it goes over Paris and it's clear in Paris, they can see ISS, and it's about 8th magnitude. So about 5, you know, easy, could be 10 magnitudes fainter than it would normally be. But light pollution is the gift that keeps on giving. Not only does it affect your terrestrial observations, it makes satellites visible.
That's a simple observation here. How amazing how things have changed over my lifetime. When, as a very young person in Marshalltown, Iowa, we would go out in the yard during twilight to see the satellite going by, and it would be announced in the paper, and people would be running out wanting to see these objects.
Amazing how life has changed. You know, I had the great privilege of spending part of my life on a planet which had no space debris. And I can remember looking up in the night sky and seeing just meteors and stars.
And very little light pollution, too.
Very little light pollution, too.
Will NORAD be able to track all these extra objects?
NORAD, yes. Most of these objects are so big that NORAD can track them without problems. But what happens now is that the operators have much better positions because they have GPS receivers on these low altitude satellites. And so several times a day, they send the positions to NORAD, to the CSPOC, which is the organization which keeps the catalog. And so they get automatically put in the space catalog. But the best positions come from the operators themselves because they have GPS receivers on board the satellite.
Of course, we don't know that the other countries will be doing that as well, right?
No, we don't.
Any other questions for Pat? Okay. Thank you very much, Pat. We appreciate it.
All right. You're welcome. I will leave you now.
So I'm pretty
Thank you,
sure
Pat.
we've given you a T-shirt in the past, correct, Pat? Did he just drop out?
I believe so.
Wow. Okay. I'll catch up with him via email. Okay. So moving into the business part of the meeting, officer reports. I just have a couple of things. One of them is one of my least favorite duties as president of the club, and that is to announce the loss of a club member. And we are an aging group. It seems like it happens more frequently all the time. In this case, it is a long-term member named Tom Rifle. I didn't know Tom real well, but I don't know, maybe Doug or Jim, who spent more time with him, we'd like maybe just say a couple of brief words about him so we know something about Tom.
Well, he was a bit of a character, and his day job was supplying auto racing teams with tires. And so if you're familiar at all with racing sport, auto racing sport, and know any of the names in it, he probably sold tires to him. So we knew all the names to know in our generation of drivers and mechanics and owners and team managers. Me, I didn't follow auto racing much at all, so I can't comment too much on that. I think he became associated with the club through Eric Webster. For a while, he owned an 18-inch Webster with servocat and everything else you can imagine on it, and started coming out here with Eric. And he was very opinionated. His Facebook was full of stuff from Occupy Democrats and other left-wing organizations. He was, in that sense, his politics were definitely secular and humanitarian, and it was fun talking with him, and he was always excited to be out at Beach Mountain. And you go through something like this pandemic, and you hope everybody gets out the other side so that you can see him again. And not seeing Tom is going to be one of the things that it's pretty upsetting about this. His passing didn't have anything to do with the pandemic. It's just that what time there was to have with him was cut very short because of it. So I personally will miss him. I know a lot of you didn't know him, but one of my better experiences in the Lowbrows, and without the club, I never would have known him. So I'm just grateful for that.
Thank you, Jim.
I'll just add my 2 cents. While I was working in Auburn Hills, Tom lived in, I think, Rochester Hills or somewhere very nearby. And I would see him maybe once a year, sometimes twice. But when he wanted to pay his dues, or if he wanted to buy a T-shirt or two for his family or friends or whatever, he would prefer to come to my office and come to the parking lot. We'd meet out there and we'd chit-chat for a while. And the conversation rarely got to astronomy. It was almost always race cars or tires or maybe his ill health, and politics certainly got into the mix too. But he was a very interesting guy, and his health was failing. Every year it was a little worse, and very sad to see him go. But I'm glad I got to know him a little bit. So,
thank you, Jim and Doug. So I'd like to just call for a moment of silence for Tom. Thank you very much. We're going to miss you, Tom. Okay, so moving on to happier subjects. Doug Warshow, who has been gotten us many guest speakers in the past and still does, even though maybe indirectly, had just recently sent myself and Dave Jorgensen just a reminder and a link to some UofM resource to look for more speakers. And Dave Jorgensen has already jumped on the case. But this was also a reminder of an email that I wanted to send, so I'll just do this, maybe send an email too later. And that is to remind everybody that all of us actually are very eligible to be speakers as well. In fact, some of our very best talks actually have come from within our own club. And it's kind of nice to intermix more things that are amateur astronomy type related things, and along with the astrophysics and professional astronomy. So if anybody's got anything they'd like to present, please get a hold of us and let us know, and we'll schedule in there. And another option is it's always nice to have speakers like that we can kind of have in reserve. As you might remember earlier last year, we actually had to use a couple of those because a couple speakers had to cancel on us. And but we came up with people, so it's always nice to have that in reserve too. So if you've got something you'd like to present, we'd love to hear it, and just let me know. So that's all I had. I'll move on to other officers, starting with Vice President Joy.
I updated the calendar on the Night Sky Network. We had only done it so far, and we got to the point where the end of the year is December. We hadn't done any more, saying that it was online. So I went through and wrote it all to be online till March. So hopefully we can have a live meeting in April, but we'll see.
Thank you, Joy. It's been so long since we've done any of those, I forgot to update the calendar. So I appreciate it. And thanks for doing the minutes too.
Sure.
Okay, how about Adrian?
As soon as I get off mute, just wanted to put a call for Lowbrow to join our next GLAC meeting. We'll be having it February, I think 11th, is it?
Correct.
Jeff?
Correct.
Yeah, we're looking for input to thoughts that we've had on repeating what we did last year and discussion of what a possible hybrid event might look like. We're well aware that if vaccination isn't working out so well, or if the CDC doesn't, for good reason, does not give us reason to start meeting in person safely, if we're not getting the direction. And I think with the new administration coming in, we're going to be getting more solid direction from the federal side of things, that we would simply go back to having an online presence once again and planning to do that. But we are also kicking around the idea of any kind of safe way to do a hybrid event where whatever is done outside is very limited, and very likely with masks, and so only so many people being able to come out to the outdoor part of the event. We're looking for ideas, and we're also looking for help with the planning committee for GLAC, so that things that were basically laying on Brian's shoulders, Jeff's shoulders, and Bob Tremblay's shoulders could kind of be alleviated with some other additional help. We do have some from other astronomy clubs that came in at the last second and jumped right in to help us out, but we're hoping to get them to come in early and give their thoughts early on and not wait until a month before to come flying in with a cape. So we are looking for some volunteers, but for now, and more important than that, for now, just folks to attend the GLAC meeting and want to give some time to give some input to what we're looking at doing for 2021. And input from all the clubs are valuable, because it was from all the clubs that that helped really make that a success, even though it was pulled together first time that we've done something online for astronomy at the beach. Yeah. So and we really owe all the clubs.
And officially, the date for 2021 is September 24th and 25th, that Friday and Saturday.
Yeah. There's a question in the chat. Well, what's GLAC? Great Lake. Let's see. I'm the president of GLAC, and I'm supposed to have this down. So
be careful.
Yeah, Great Lakes Association of Astronomy Clubs. And please correct me if I'm wrong. But it's a governing body for, I'm not even sure if I can call it a governing body for all of the astronomy clubs. The main event that GLAC puts on is Astronomy at the Beach, where all of the astronomy clubs in Southeast Michigan, and I think even some from other areas, are invited to participate and basically share the night sky with the general public. Up until last year, it's typically a huge event that attracts somewhere around
it's about 4,500
Brian
people.
Adam is here. What are the numbers we usually attract? 5,000, is it? People or
somewhere in the neighborhood of 2.5 to 4.
2.5 to 4,000 people over 2 days.
We've had
come
as
in.
many we've had as many as 15,000 back in 2003.
Wow.
Okay, so that gives you a great scope of how big this event has usually been.
And in a normal
telescopes Go ahead, Jeff.
I was saying in the year that I first went was 2019, before all the pandemic struck, and at that year we had over 70 telescopes in the field. So if you can imagine an entire beach park area covered in guys with their telescope gear, and crowds could basically wander from scope to scope and see whatever the astronomers were showing them. And I had my telescope as long as the battery lasted, for about 4 hours, and we never had fewer than 30 people in line who were all enthusiastic, and I mean, they had a great time. It was disappointing to do an online thing last year, but it was the most practical, and even being online, we had great attendance, had lots of people there. So regardless of how COVID's going, it's going to be a great event no matter what. And
yes, and if anyone wants to share their astroimaging, their real-time astroimaging abilities, we had great shows.
Don.
Paul Goltz, Don Swetzik,
Oni Hufford.
Yeah, Brian, Jeff.
Yeah.
We really had a very energetic event that went off quite nicely, given that we invented the wheel. So come to the planning, become part of the planning committee. We need the input of all people who really want to see an event like this be successful.
Yeah. So that's what I'm going to stash into my lowbrow report. I don't have any specific lowbrow news, but as far as GLAC goes, I wanted to take the time to invite you all to come to the meeting. I'm going to be doing the same with the Warren Astronomy Club when that meeting goes. So.
And they are Zoom meetings just like we have here, so everybody's familiar with how they work.
Yep, Doug Bach knows about them. He's on. Doug's a part of lots of clubs, and good to see you, Doug. But that's it for my report.
Thank you, Adrian. How about Jim Forrester?
Not a lot. This afternoon, an email came through from the local Dark Sky Initiative. One of the people on the email list saw that MLive had published the schedule of public nights at the I can't remember the name of it. It's a Lawless Dr. Lawless park. It's managed to get the IDA dark sky park imprimatur like the Headlands, except that part of the state, unlike the Headlands, is not dark. And so how they managed that, I'm not sure, but they did. And they're trying to be active, but there's nothing on that website. And Jenna checked out the park's general website, and there's nothing there about how they're managing to do any events, let alone nighttime events in the pandemic. So I would caution everybody about going over there. But at some point, I would like to visit that park and see what they've actually done with it.
Yeah, I saw closing times on the weekends of 10 p.m. And to me, in the summer, maybe the summer hours are better, but to me, you have a dark sky park and you don't leave it open beyond a certain time. what business do you have being a dark sky park? Because it's the overnight where your skies get the darkest and you do most of your observing or imaging. So that's something I don't know if they post those hours for the general public, and if you've got a scope or equipment, they let you stay overnight. Yeah, I want to see what that's all about.
Yeah, I'm just worried about them killing people. But,
that too.
Oh, that.
Probably more important.
Yeah, and we also had a brief discussion among several of us about Peach Mountain, and pretty much the consensus is, given how out of control the pandemic is, it's not really a good time yet again to approach the university about using it at all for even just the membership. So that's it.
Thank you, Jim. How about Doug Scoble, live from Traverse City?
Live and in person. Well, not in person, but here I am. So since, this is going to be a little surprise, but since our last meeting, we picked up 6 new memberships.
Woo! Whoa!
Oh.
Up to 161.
Wow.
And there were a couple that I saw, I think, that were new. There's one I didn't mention that I see on my screen now, Lynn Erdl. She just joined. She's Jeff Copemanus's friend from work or coworker or something. So I see her. So welcome, Lynn. I don't see any other new names here on the screen. But anyway, 161 memberships. We've got $9,603.14 in the treasury. We're getting a lot of money coming in, obviously, with all these new members and all that. Not many expenses. We also received yet another $50 donation in memory of Bernard. So those are the highlights, and we're cooking along pretty good.
161 members.
If anyone needs reimbursement for anything, I see Don there. It's hopefully his shoulder is coming along, and if you have money I owe you for the newsletter, let me know, and I can send you money for that. So that's my report.
I'm still impressed with that number. That is a new record.
Yeah, that's a high water mark.
Yeah, very nice.
One thing I'd like to add, Tom Reichel's family donating. Tom was suffering from cancer, and at the very end, Alzheimer's, and so the family suggested sending contributions in his name to the Alzheimer's Association.
Okay, our newsletter editor, Don Foley.
Okay, as I mentioned before, this is my last term as a newsletter editor. So I've got 3 more issues that I'm going to put out, the February, March, and April issues. And when I send the newsletter out in my email, I'll also put out a encouragement for other people to be the newsletter editor, and we'll see how that goes. Don't have a lot of material for the February issue, but we've got a couple of weeks yet for some things to come in, and I've got an article promise that should be interesting. So I'm confident I'll have an issue in February that the membership will enjoy. That's all I got.
Thank you, Don. Jeff.
Our peak tonight was 43, and I think it was 38 on Zoom, and I think we peaked at 39, and we had up to 5 on YouTube tonight. Otherwise, everything went smooth, and aside from a wonderful Saturday night that was very clear and very cold, I got a very nice picture of Orion, the Orion Nebula anyway. That's it. Short and sweet.
Thank you, Jeff. And our observatory director, Jack.
Well, I've been out to the observatory a few times, and the building's still looking good. There are no really major problems out there. Road's okay. There hasn't been that much snow out there, so that's worked out good. The one thing is going on, I know I've been asked about the internet connections out there that we talked about before. I think a lot of that's put on hold because of this whole issue with the AT&T tower that's supposedly going to be built out there. So I think that's going to be an issue that needs a little more understanding as to what type of reception we would get off that tower, and is that tower going to be useful to the people or groups out there at Peach Mountain College of Engineering, SEAS, and the UofM radio tower group. I don't know. A lot of controversy. Some people don't want it built. Some people do. So we'll have to see what happens at the February meeting. Other than that, that's all I've got about the internet and the observatory and what's going on out there right now.
Thank you, Jack. And I didn't see Dave or Christian out there, so that would complete our officer reports. Do any members have anything? Nothing? Well, then do I hear a motion to adjourn?
Motion to adjourn.
Support? Support. All right. Thank you, everyone. We'll see you next month.
All right.
Okay. Night, everybody.
All right.
Good night, people of Earth. Okay.